So from that, what we get is we get from that unit circle activity with the paper plates and stuff. We want to then take that next step and say, well, how do we use that unit circle now to sketch what these functions are? We've done in Unit 1, we've done step functions, we've done hybrid functions, we've done quadratics, we've done cubics, we've done quartics, we've done linear functions, we've done reciprocal functions. I think that's about it. Let's now step into what are these a sine dx. What the heck is that? What does it look like? And we're going to use the unit circle to do that. So if you're not sure what it is, maybe stop the video now, have a look at, type into your computer, go to GeoGebra or Desmos, type in a sine, it'll ask for the parameters. You want to put sliders in for A, B and C and D. You can put numbers in, I would, but put numbers in, 3 sine 2x plus, pardon me, plus 1. Make some of them 0, keep changing the numbers until you get that conceptual understanding of what's happening with those functions. I think it's better done using these, using this hands-on approach. But you can use technology to take an investigative approach, and I think that most teachers would do that. So you might start with sine x and type in 2 sine x and 3 sine x and 4 sine x. What happens if you change a? So you'll find that a is, tells you what the amplitude is. So the bigger a is, the greater the amplitude. The difference between the trough, or the peak, sorry, the crest and the median line, or between the trough and the median line. So if a was 2, it would go from positive 2 to negative 2. If a was 3, it would go from positive 3 to negative 3. Write that down. And then you'd say, well, let's not even put a in there at all. Let's go sine x and go sine 2x and sine 3x and sine 4x. What happens as b gets bigger? You get more of those peaks and troughs in between 0 and 2 pi. How many peaks and troughs do you get between 0 and 2 pi? Is there a relationship between that and b? What happens if b now is a decimal? 0.5, 0.25. What happens then? So you can take that investigative approach if you like, and there's nothing wrong with that. It's really good. Really good. You can do that. I'd probably do that as a result, afterwards, but after I do the paper plate activity. But I won't need to do it quite as intensively because kids have got a really good understanding of what the sine and the cos are. So from that, now we've drawn the graphs there, hopefully we've got a relationship between, if sine graph goes like this, how do we know that in the first quadrant that sine's positive, second quadrant sine's positive? That's what the graph says. Do I actually understand the graph? And if I do understand the graph, the cast rule or the all stations to central rule, or I don't know, there's probably lots and lots of different ways of saying the mnemonic ASTC. But from there, once we get that cast rule or all stations to central, they're the ones I was taught when I was younger. We can have a look at, when we're looking at, say, the sine of 3 pi and 4, we're expecting a positive answer. Or if I have to solve the equation sine x is equal to positive 1/2, I know that I've got 2 quadrants, so it could be the solution to that equation. And we're going to need that particularly when we get even later in Unit 4 and we start doing the ambiguous case for non-right equal triangles. So as I said, when we're solving equations, solving that equation there, we got sine x equals 0.5. We could just simply use our graphics calculator to work that out. But what you notice there, what I haven't really determined here is what's something that comes through from Unit 1 quite a lot. It's quite strong and quite focused. I haven't given you what the domain is, for what values of x am I actually asking to solve that. So maybe start with something simple like that. What is the, solve the equation sine x equals 0.5. I'm going to use my exact values. Sine of, 0.5, what's that? Pi and 3, isn't it? Sine of pi and 3 is 0.5. So that sine of pi and 6 is 0.5. And so I might say pi and 6, 30 degrees. But hang on a minute. Isn't sine positive over here? Then start looking at extending the solutions. little bit further on. The other thing I could do with it, instead of getting that discussion starting, would be to actually state the domain x is between 0 and pi and 2, or x is between 0 and pi, or x is between 0 and 2 pi, or x between negative pi and positive pi. I could ask those questions, but then if I do stipulate the domain, I'm not really asking for a lot of discussion. I open it up a bit more, I can get more discussion onto it. And that's what we want to do. We want to get the kids talking more. We want to get them to really think a little bit more deeply about, you know, well, hang on a minute, I've just done this. You know, it's also positive in the second quadrant. However you do that, I mean, me personally, I want to open up the questions. And if they're still just stuck with, yes, it's only one answer, then I might, you know, as the teacher, I might just push that discussion a little bit. What about if it was in the second quadrant? Ah, of course. And then you can layer those questions on top of that. Keep layering and keep sequencing the learning to get more and more thought processes involved. Okay, so then we go on to, as I said before, Unit 4, and then we're looking at the sine and cosine rules. We've done all those graphs, beautiful graphs, fantastic. And so we just reviewed just quickly the sine, cos and tan rules. Golly, in Unit 4, we're talking about just before they get ready for externals. You might ask a question in an exam from a right angle triangle, but really of all the things you can assess in Unit 4, it's not something that I would be prioritising very highly. Mindful of the time. The unit circle, we go back to that and the periodicity of the angles using degrees and radians. We want to look at the ambiguous case a little bit more. Area of triangle, which is quite interesting because in Unit 2 in general maths, you do area of triangle using half ABC sine A. But you can see there the key thing here is that not underline, but establish and use. So how do we establish them? Do we have to prove them? Something to think about. If I'm just looking at the use bit, but how do I establish that? That's the thing that we need to do. And constructing those mathematical models there, we've got a lot of scope there in terms of bearings. We can use three-dimensional geometry also to develop those ideas. So deriving the sine and cosine rule, I wouldn't use a great deal of time on this, but certainly if we establish them, I think we can just quickly prove them, even if you just want to use a YouTube video, because they're not going to be asked to prove it in a period of in an assessment piece. I certainly hope not, because the key thing there was, if you saw the underline and italicise, was to use it. But we would develop them, and if you wanted, we can do that in the tutorials. So the only thing I'd say about the sine and cosine rules, if you look at the formula sheets, the sine rule is only like A over sine A, B over sine B, C over sine C, and you'll see in literature, flip that upside down, sine A over A, sine B over B, and sine C over C. And same with cosine rule, C squared equals A squared plus B squared minus 2AB sine C. And then they'll give you, cos C, and then I'll give you the cos C equals this is over. And I think, well, I don't know, the more things I've got to remember, the more things I've got to forget. So that's what I was taught when I was younger. So they're there for them to use. They're there for them to use. So why not use the two different versions of each of those? Because the key thing is to use them, and let's use them in context. Okay, let's use them in context. That's it. So a bit shorter this one. But what I would advise you to do is to go back and have a look at those manipulatives on that slide. In terms of the using the paper cups, using the radian measure, and also this right hand or left hand rule. And so in your tutorial, just to sort of cover that again, developing the idea of the radian measure. And so maybe you could, in the meantime, maybe as part of stopping the video at different times, re-watch it, just what is a radian? Just go back and have a look at what that means. The unit circle, solving equations, sketching functions. It's going to be quite intense in the tutorial, and probably we will do a little bit on the sine and cosine relevant area of triangle. Okay, thanks very much for listening. I'll see you guys next week, and we'll also catch up with you in the tutorials. Thank you.